We are live. All right, welcome everybody. Glad to have you guys here. I'm going to be covering animation and how we can use animation software and how we can really take what we know of really just basic physics of motion and apply them to a basic animation and then explore the different ways to make objects interact with each other and make effects and make those effects based on the different objects and how they interact. So, if you have not been familiar with this software, this is called Adobe Flash. I'm not the biggest fan of it. I'm most familiar with it, but it does the job for now. I'd be willing to look at other softwares out there that do animation because it's not the most reliable, but we'll work with it for now. And instructions, and yeah, this is the boring stuff, but it helps sometimes to look at instructions, like getting a plan, like state the goal, plan the process, build the process, etc., etc. So what I've stated, okay, is just animate a ball rolling and knocking over a rectangle. So it's very simple, nothing complex, nothing too detailed. And then instructions are the rectangle will fall over. Rectangle will fall over and fall down a hill. Okay, so it's two actions we want the rectangle to do. Collision effects will emit at the point of the ball colliding with the rectangle. Okay, so we'll explore that, what it looks like when the ball hits the rectangle and what we can do. So if we want to plan out a process and a formula, right, you can kind of look at that different ways. But it helps, and we'll get onto the graphics right here after this. It helps to define what the objects are. What's the weight of the rectangle? What's the weight of the ball? What's the physicality effects of, what's the physicality of the effects? So is the rectangle light? Is it heavy? Is it like ultra heavy? Same with the ball. Is it a ball? Is it a light ball? Is it a rock? Is it a bowling ball? Is it super heavy? Is it a boulder? And those are all going to have a different effect on the objects they're colliding with. And then what's the physicality of the effects themselves? Is it electric? Is it static? Is that what you want to make? Do you want to make dust and particles? Do you want to make cartoon? What I'm going to do is I'm going to make cartoon lines, expression shapes. And then the building process is basically one layer for the collision objects, one layer for the actual objects, oops, and one layer for the grass and the sky. There we go. All right, so that's what we've done. We've one ground layer for the grass and the sky, one objects layer, that's for the objects, and then the collisions, you can slowly see right up here, the keyframes are going to be for that. All right, here we go. Yeah, let me get to the sample of what I've started. So I have total of, so far, 10 keyframes. And I have it where the blue ball here, is rolling in. And it's about an inch apart on each major keyframe. And then each keyframe, what I'll do is I will go back later and add in between frames. Let me zoom in a little here. And you can follow along by the keyframes. This is keyframe 1, keyframe 2, and I just added a small shine right here, really simple one to indicate the location of how it's rolling. Keyframe 2, keyframe 3, that could use improvement because notice the relation between that one and that one is very far. Relation between that one and that one is very close. So if you play them all together, that looks like it's slowing down. Now I could do that, but maybe I don't want to do that. Right. So the one after that, that's about moderate between there. So that's a fair distribution of locations between these three. So technically, I would be smart to move this closer, right? 1, 2, 3, 4, right? And I added a little ramp on here, but I did not include that on the instructions, but I could. The animation software does have a feature called onion skins, where you could see, and I just gave away part of it, but it's showing you the current one, the one previous, and the one that's coming up, and then one more after that, right? Two previous, that's the current one, that's the one that's coming up, so I can see they're fairly well distributed. Maybe if I wanted the first one not as far, or maybe a little farther, right? I could put it out here, and this is how it would look. See that previous arrangement? That would be very hard to believe, right? So it's hard to believe that this is, unless it's slowing down. So that's why you want it to be kind of even there. So that's a little even. Okay. So now they're all working together. And then here comes the collision point. And then I will turn off the onion skin. All right. 1, 2, 3, 4. Bam. There's your collision. So it's collided, it's impacted. And what is happening now? Now you have the cartoon effects of the lines, of the impact collision effects. And also, these lines are a specific style where they're just kind of like these points. And if you do something like that, you want to have maybe like a vanishing point, like they're coming out from that point, going out that way, going out that way. If it's dust, that could be also a vanishing point. If it's if it's static, if it's any other material, they might have a vanishing point, but it might be more dynamic. And then the following one, they disperse. Now they're dispersing from the vanishing point. So the vanishing point, we could say, is like right here, where the collision. We could move it down a little more if that's the collision right there. But notice they're dispersing from the previous point, and they're dispersing even more as that thing continues to go. As opposed to moving along with the ball, the lines are not following the ball. The lines are independently dispersing. We could actually take that off, right? Coming out here, expanding just like that. So they kind of relocate, recenter, and then expand. And it could definitely be defined. It could be definitely fine-tuned. If I did that, maybe. Because you went point from there, point from there, point from there, right? And now it looks like it's going out. Looks like it's curving around. Yeah, now it's flying everywhere like a snowflake or something. So that is just, I'll change the background here as you can see this better. See, that is just that is just an orange line, which I drew by hand. But if I want this consistently coming out from that same location, I have that line. I don't want it to look like it's any other material. I want it to be, it's almost like static, but it's like cartoon static, right? So now they're vanishing, coming out, coming in. Okay. So that's on its own layer. That's the effects layer. Let's put the ball back in. And once, the thing is, once it's here, you kind of have to keep it. You got to commit to it, unless you want to move the location of the vanishing point, which you got to do for every single subsequent line, or vanishing effect line. So let's look at the impact here. We put the background back on light color. Sort of a gray. Okay. It's rolling, collides. Now, is the rectangle heavy, or is the rectangle light, or is the rectangle super heavy? And that, I'll move some of these menus out of the way. that will determine what is it going to do. Like, because if an object is heavy enough to tip over, it'll just hit the ground and it'll stomp on the ground and it will not move at all. And that's the end of that motion for that red object. But what if it has, here's where we can start to get creative. What if it has a little bit of lighter weight to it, or a little bit of what's the word? Buoyancy? No. A little bit of something else to it, right? You want it to give it some life. And what I'm doing here is adding extra keyframes that follow that fall, which will give it some sort of bounce. So does that mean it's lighter? Does that mean it's heavier? Does that just mean it's bouncier, right? And then it bounces, but here's another problem is that if it, even though it's bouncing, well, it should also impact with pause another surface, right? So it won't be able to bounce on a non-surface. It won't be able to bounce on a surface that it's going to fall off of. So, density. Thank you, Loki. Thank you. Density equals weight. Yes. So it has density, and it's colliding or it's impacting with a surface, a green grass surface that is 100% solid. And originally I was going to have it slide down the hill, but on this one I want to keep that bounce effect. So let's watch it. Knocks it off. It falls slow. It is a slow fall. Hits and does a small bounce and then rests. So let's loop that. And I will slow down the frame rate. 30. I'm taking it down to 15. All right, it's half. Zoom back out. All right. And then the ball just kind of sits there in the air. Ball is only flying. The reason ball is not continuing to roll is because supposedly ball is lifting off. But it really kind of took its time to say goodbye on that red rectangle, because it's just kind of sitting there for a little while. And now let's exit stage, and we're off stage with the ball. Okay. So the rectangle may not be as heavy as we think it is, or is the ball heavy enough, or too heavy? So that, defining what the weight of the object, well, defining the weight of every object really helps you, kind of like if you're doing programming, you're making variables. Defining what each of these things are going to consist of helps you um, make sense of the rest of the scene, make sense of the rest of the activities that are going on in here. So let's play with some of this idea um, on what it can do, at different speeds. Let's see. Yeah, makes sense. Okay. Um, go ahead and comment on what you think the weight should be, or how can we test this? Like, what kind of tests do you think we should run to kind of get the most realistic and cartoonish feel, if that's what we're going for? Realistic and cartoonish meaning it has cartoon feel to it, but it also follows some more closer to realistic physics weights, uh, laws. Sorry, physics laws. Okay. So what I'm going to do is I'm going to take my keyframes, move them out one, add one here, bring the ball back a little bit. So that way it's I'm giving it more frames right here. 1, 2, 1, 2, 1, 2, pow. Now instead, I don't want the ball, pow. I don't want it to fly. I want it to fall back because it's a very heavy ball. It's like a bowling ball. It's like, da, 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 boom, never mind. And so it's going to return, da, 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 pow, and then return 1, return 2, right? So 1, 2, 1, 2. I'm going to rotate it. 1. So really the rectangle was a little too heavy for it. The rectangle was too heavy, so heavy that the ball just retracted, retreated it, whatever. All right. Let's see how that looks. Expand it. Yeah, it really just nudged it over, right? Okay, let's do about 10 keyframes. And another thing, what I want to do is add more actual keyframes in here, up here. But right now I'm just slowing down the frame rate so it goes slower with fewer keyframes. Pow, right? And these things can disappear just like that. And background do I want? I want a background with better contrast. No, that looks terrible. Let's just do solid black. Okay, reading the comments. Loki saying, I'm trying to follow along and do my animation and do my own animation with yours. Cool. Pow. Pow. And I wonder if the bounce is a little too, it's too bouncy because it's if it's strong enough to knock the ball back, then it doesn't seem like it's going to have as much density. It can definitely keep the collision, right? And in another way, what the ball reminds me of, it almost reminds me of like a mischievous creature just walking up, knocking it over, and walking away with, you know, dismissing all responsibility from knocking it over. So instead of that bounce, what I could do is modify the background to where we're not going to worry about representing the weight with the bounce. We're just going to let it fall. So we hit impact 1, impact 2, impact 3, impact 4. And the next one should be, and here's one trick. Notice my points, my pivot points. Pivot points meaning it's resting, it's the rectangle's resting. It's like your feet when you walk. Which feet do you put your weight on each step that you take? They alternate, right? That could be a little further back. So when the weight of this rectangle is right here, right on this right corner, and I'm using a tool in here to give it that that. Notice this little white dot right here. It will rotate around the white dot. See how it's going around and around, circling that. So I could put the white dot right here in the center. That's usually by default, that's how it is, and it just rotates that way. So what I want is a representation of the weight being right here. So then I do that, and that weight, I can just easily move it that way, and so forth. So that if you have a tool like that, or if you easily move it that way, and so forth. So that if you have a tool like that, or if you just hand draw it, keep that in mind, um, as a metaphorically, um, where is your weight resting on, and each previous subsequent frame, that's where your weight needs to be consistent with. It needs to be consistently uh, resting and responding to that point. So, okay, bam, hit one, hit two, it's falling slowly. Hit three, it's falling slowly. Four, I think it should be like if you watch like a tree fall over, it falls slow and then very fast. You know, somebody comes and knocks over the tree, slow, right? A giant bird knocks over a tree, slow, pow, just like that. That was too dark. Yeah. Somebody knocks over a tree, falls slow, pulls up weight, and then hits the ground. Hits the tree slow, hits the ground. So let's see how that looks. Bam. Okay. Bam. Bam. And now we're on the edge right here. We're about to fall off the edge, and the next one shall be your weight is over here. Weight is right here on the edge. Funny how that works. How you're at one place, kind of like when you walk. You take one step with your left foot, your weight is on your left foot. Then you move it to your right foot, your weight is on your right foot. Back to the left foot, so forth. Right here, weight is on the bottom right of that thing. Weight is on the bottom right. Weight is on the bottom right. Weight is now has moved from the bottom right basically down to the center. But since it's also kind of top heavy, we probably could define that somewhere. Now the weight is going to be pulling from here, right at this point. So, and also there's no surface below it. So uh, it needs to follow. Let me see if I can move it here. Will the program be cool with that? Yep, it's cool. It's cool. Right there. Now I've moved my little node thing right over here to this corner. The node is on that way corner. Now I can start to move it that way. Or maybe right here. There we go. Almost. Pulling down. Nope. There we go. So now we're sliding down. Now we're sliding down that hill. And I can move it again. Actually, that's incorrect. Uh, actually, that's incorrect. Um, it should be right here, right at the edge of that hill right there. Okay. I don't know why I overlooked that. Now we're moving. And then press it down. Because the force is on the right end, it's going to have more gravity moving in that direction. And that little node really is just supposed to be a helper. It's like if it works, it works. And the last one. See how that can get annoying if it's not positioned, if it's not setting its weight on anything. It's like, wait, move, 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 but it won't move. So now you have to really define, okay, there we go. So this part will depend on a lot of different things too, because what's your rectangle made out of? Is it a top heavy tree? Um, is it just a cardboard box? It's going to have different effects, um, or it should convey different things, to, depending on what the physicality of that object is. And I think that's actually too close. This last one. All right, let's see how that looks. It's a bit of a slide down. Um, I gotta wonder, should it be should it be faster? It's kind of one of the first questions you might come across. Does it go all the way down? What's down at the bottom of the hill? The blue ball looks like it's got more energy and more persistence than the red, kind of a lazy red log, right? Let's see it. Let's see what it does if we give it fewer frames. So this should be less close, further from each subsequent frame. Knock over, knock over, fall. That's a slow fall. Make it a faster fall. Okay, at least that what I'm doing on my end. Um, okay, loop it. Loki's saying loop it so that the block falls into it, then falls out of the sky where it was. Oh, that's a good idea. Yeah, like this is the exit of the dimension, and that's the entrance of the dimension, or whatever. I'll give that a shot, like Pac-Man. I still feel like this should be sooner, like the top of that, the bottom of that is sooner. It's having some physics issues there. That's funny. Okay. Okay, so down at the very bottom. And then this one will be coming in from the top. there's a snap feature on here. There you go. Alrighty, let's see. That's a good possibility. Now, another thing we could explore would be put another ramp. We could take this ramp, duplicate it, and put it over here. So this way, it comes in, goes up the ramp, stops right there. Returns. And keeps going. Then we take these, duplicate all those keyframes, paste them, and now you've got your repeating ramp ball. So using that approach, you want to be careful that one, is it on the right keyframe? If you're going to duplicate keyframes like that, are you duplicating the right, are you starting the same point, and is it kind of evened out like in the timing? Because you could see it's like fast and then slow and then fast and then slow and then fast and then slow. And then the red rectangle also has to return. If it's going to loop, the rectangle has to return to its position. If we did that, so that might not be the best one. Cool deal. Well, this is an intro. You guys have any questions, any ideas that you'd like to see explore on this video? Let me know. What I can do is distribute these out further. So that people can appreciate the firepower. Loki saying, no, I'm good, just working on mine. I had to make the scene during your intro, so I am just now animated it. Nice. Yeah, hopefully share it on Discord if you'd like, or on YouTube. And the reason, okay, so if we look at 1, 2, 3, these stop here. Let's see, looking at the particles. So the particles, bam, 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 and then stop. Okay, so there's a freeze right there in the particle. I wonder if it should be, keep that there, and then bring these in. So the more you bring those things in, you bring in, kind of particle things in, the kind of the slower it's going to disperse. But you do want to be careful because it's like you see it, it's not moving. And I could just delete. Yeah, I could do that. I could delete that one. This one doesn't, it's gone off the stage. So it's the other one. So it's a very slow dispersion there. So let me go back to 20. Very fast. And because if it's too fast, then yeah, you can't really appreciate the motion of it. Back to 10. What do they call it? The fast forward effect when you play it in fast forward. It's too fast. So now I'm going to go ahead and I'm going to disperse these, kind of separate the keyframes out to where like that's one, that's one, that's one, that's one, that's one, that's one, etc. Now I'm going to make it 2 frames a piece. So that's 2 now. And then move that out. That's 2 now. Move. That's 2. That's 2. Yeah, the impact now has to just move out here. There we go. So now we can actually speed it up. Alrighty, well, hopefully that's been giving you guys a good intro. It's 2 frames, and then we spin it up to 20 frames. I'll go ahead and post this onto Discord, and thanks for joining. Alrighty, see you later.